Hello, hello. Here we are again. Today, you guys, we are talking about factoring special products. So we're just coming off of factoring in the form of ax squared plus bx plus c and basic x squared plus bx plus c. So now what we're looking at for this lesson is we're looking at factoring special products. So our essential question, how can you recognize and factor? So that's a really big word for us right here. Like we have to be able to recognize these special products. Once we're able to recognize them, factoring them is actually going to be pretty simple, but we have to, recognize. All right. We're going to jump, woofda, I jumped too far. We're going to start by just looking at our first core concept. So this core concept says that we are finding the difference of two squares. Finding the difference of two squares. So a squared minus b squared. What we're able to do, you guys, is we are able to basically take and it's funny because we've actually worked the opposite way where we were given a plus b times a minus b, and then we were able to come up with a squared minus b squared. Again, just one of those situations where we're working backwards. So here, we're going to be given x squared minus 9. What we have to start thinking about and recognizing is, hey, 9's a perfect square. So what we're able to do is we're able to start by just breaking it up, kind of like just the way that we get into our mentality. That's x times x. Now, how do I, first off, notice that we don't have any middle term, which means that number one, you have opposing signs. You have one sign that's positive, you have one sign that's negative. The other thing is that this back number right here has to be a perfect square. And when we think of 9, and we start thinking about our factors of 9, that's 1 and 9, 3 and 3. So we know that this needs to be positive 3 and negative 3. Again, if we kind of start thinking about our factoring side of things, if I do my outsides and my insides, I get negative 3x and I get positive 3x. So these just cancel each other out. Okay, so that's the basic gist of our first page of examples. So let's take a look at these two examples, and then I'm going to encourage you guys to do the next 4 on your own. So let's take a look. We've got x squared minus 25. Okay, again, this is the difference of squares. Okay, so first thing I'm going to start out by doing is I'm just going to set up my parentheses. I've got x and x. Next thing I'm going to look at here, I know that I've got a negative and there's no middle term. So I know that these signs have to be different. I have to have a positive and I have to have a negative. Again, 25 is a perfect square. That's 1 and 25. 2 doesn't work, 3 doesn't work, 5 and 5 then. So that's got to be positive 5 and negative 5. And that's really all there is to it with this example. Now, for example B, this time the perfect square actually isn't on the back like the last couple of examples, it's right on the front. So first thing I'm going to do again is I'm going to set this up. There's no middle term here. So the next thing I'm going to do is I'm just going to start throwing in the positive and the negative. Now, I can start by putting 1 and 1 here because the only way we're going to be able to come up with 1 is by 1. But we have to start thinking about how am I going to get this 4z squared into basically canceling itself out. Again, 4 is a perfect square. So I'm going to use the numbers 2 and 2. And then if we start thinking about z squared, the way I can break z squared up is that's z times z. So that's got to be 2z plus 1 and 2z minus 1. All right. You have 4 examples right below that I really, really encourage you to try. Number 3 and number 4, also 9, 16, 16, 49, those are all perfect squares. So just keep that in mind. But this time they just have you doing both of them have perfect squares. So both your A and your B are perfect squares. So pause the video, try these few on your own, and see what you can do. All right, so here they are. Here are your solutions. For number 1, pretty straightforward, just like the very first example we did together, x plus 6, x minus 6. Number 2, somewhat similar, I guess. Actually, no, it's not. I was going to say it's like example B, but it's really not. Actually, 3 and 4 are more like example B. But really all that happened, you guys, with number 2 is they just switched. So instead of having the variable first, they had the variable second. Nothing super crazy, nothing to really freak out about. They just switched the order. For number 3, this is one where you just kind of had to pay attention. 9 is a perfect square, 16 is a perfect square. So you're just coming up with those perfect squares, 3n and 3n, positive 4, negative 4. Again, if you were to FOIL all of that together, these insides and outsides would just cancel each other out because you'd have negative 12n and you'd have positive 12n. So again, just cancel each other out. Same thing with number 4, 4h plus 7 and then 4h minus 7. 7 times 4h, 4h times negative 7. Again, you'll end up canceling each other out. Okay. Next page. So I think what I'm going to do is I'm going to do this core concept. I'm going to do example A, B, have you do 9, 10, and 11 on your own, and then I'm going to be done with this video just to kind of shorten things up a little bit. All right, now this time we have a perfect square trinomial. Again, we've worked from these, from A plus B to A minus B, and come up with this. Now we're just working backwards, where you are going to be given this A squared plus 2B plus B squared, or A squared minus. So really the only difference here is those two. And you're just gonna factor it. You're gonna break it down. Okay? So take a second, get these written down in your notes. Highly, highly suggest you guys that you write the examples down. Because remember, you're getting points for these notes, so make sure that you get them down. In the example, so like, again, here, you've got positive and you've got negative. That's the only difference between these two. What you're trying to do, and really, I'm still going to do the factoring method because that's just kind of the way my mind works. I'm going to think of what are my factors of 9 that when I add them together are going to give me 6. That's going to be plus 3 and plus 3. And then we're able to just simplify and say that it's x plus 3 squared. Okay, kind of the same concept. I've got x and x. What are my factors of 9 that are going to give me negative 6? Well, these both have to be negative then, because when I add them together, my answer needs to be negative. When I multiply them together, my product needs to be positive. So that would be negative 3 and negative 3. Again, I'm just taking this whole thing, and that's turning into that x minus 3 squared. So let's go ahead, let's do A and B together, and then you guys will pause the video, you'll do 9, 10, and 11 on your own, and then we'll be done with this video. You're still gonna have another video, so don't think you're getting out of something. Okay, taking a look at letter A to begin with, first thing that I'm gonna do, just because this is the way I'm hardwired, I know that they showed you guys this method back here, where you can just do, okay, 2 times your A term, and then times your B term. My mind doesn't work like that. If it does, great, you can use that template. But that's just not the way that my mind operates. I think better in the forms of let's just factor. So what I'm going to start by doing is I'm going to start by putting the n's there, because again, n squared is just n times n. Now I've got to think of what are my factors of 16 that are going to give me 8? Hopefully you guys automatically start thinking to yourself, okay, well, that's got to be 4 and 4. And if it doesn't come really quickly to you guys, just start writing out the pairs. 1 and 16, 2 and 8, 3 doesn't work, 4 and 4. Okay, you'll come up with that. It's going to take time. You're going to start slowly but surely coming up with these factors really, really quick. It's kind of like a puzzle, actually. It's kind of fun once you get the hang of it. So then what you're able to do, because they do want you to recognize that this is a special product and that these two terms are the exact same, you could just condense it and say that that's n plus 4 squared. Now for letter B, the thing about this one is that there is an A term and there's a C term. Now, we had a really, really good question asked today in class, or depending on when you're watching this, a couple days in class. How do you know when you're supposed to use AC split or when you're supposed to just do regular factoring? So the other day, I kind of talked about how, look at your factors. Are your factors all perfect squares? Like, are there numbers that you can take out? In this one, when you look at it right away, you're not going to be able to pull anything out super, super nice. So here is where the recognition side of things, remember in our essential question, it says, how can you recognize special products? We have to recognize that this A term and this C term are both perfect squares. Both 4 and 9 are perfect squares. So this is just kind of one of those times where if you feel most comfortable doing AC split, go ahead, do it. What's 4 times 9? Okay, well then I've got to be able to find my factors of 36. My factors of 36, 1 and 36. Let's see, 2 and 18. Then I've got 3 works, 3 and 12. Let's try 4 now, 4 and 9. 5's not gonna work. 6, okay, 6 and 6. Okay, perfect. You could split that up into 6 and 6 if you really wanted to, but recognize, you guys, AC split, like you guys have expressed, it's a little bit of work. But if we can just recognize that these are both perfect squares, I'm gonna separate this up into 2x and 2x. I'm gonna use 3 and 3. Again, this time I have a middle term, but what I want to start thinking about is that I want that middle term, so I need to have the same sign. Since this is negative here, both of my signs have to be negative. So then I've got 2x minus 3 squared. Ooh, that looks like a weird 2. But that's 2x minus 3 squared. Okay, so here's 9, 10, and 11. I want you guys to try these on your own. Pause the video, and then I'll be back in just a second. All right, ladies and gentlemen, here we are. So for number 9, should have come up with m minus 1 squared. Again, what are your factors of 1? When you multiply them together, or excuse me, when you add them together, will give you negative 2. Well, that's got to be negative 1 and negative 1. For number 10, what are my factors of 25? When I add them together, will give me negative 10. Okay, again, that's negative 5, negative 5. Number 11, kind of an interesting problem. Again, we have to be able to recognize that 9 and 36 are perfect squares. Once we recognize that they're perfect squares, we can take that 3z plus 6 out. And actually, now that I'm looking at this problem again, I kind of just didn't even really think about it. But there's actually another way that we can go about this now that I look at it. Look here. I've got 9, I've got 36, and I've got 36. Is there a common number that we can take out of here so that I don't really have to deal with that 9? Yeah. I'm actually able to start off by taking that 9 out of there. So that's going to be 9z squared plus 4z plus 4. That makes this problem even easier. Because now it's like, oh, okay, well, z and z, and then plus 2, plus 2. Okay, well, now I've got 9, and then that's z plus 2 squared. All right, so this is going to be the end of this video. Make sure that you get yourselves caught up. I'm going to come back in the next video. We're going to talk about this problem right here. You're going to do 12, 13, and 14 on your own, and then we're going to do the word problem together. So enjoy.